All right, welcome back. Now, if you were in my presentation earlier today with Jakub, you know that one of the topics that we discussed, we touched on it ever so briefly, was monitoring. And it is no surprise that now we've got an entire session devoted to the topic of observability. Now, this is such a big topic. We don't have one, we don't have two, we have three presenters for you. So without further ado, take it away, gentlemen.
All right, so thanks, Nate, and hi, everybody. We're happy to be here, and thank you for joining us. So today we are going to talk about our experiences of implementing observability, particularly for the enterprise customers. And before I do that, I'll quickly introduce ourselves. So who we are. So I'm Nitin Gokhale. I lead in Mphasis, our DevOps and transformation solutions services, and I do work with a lot of our customers to implement DevOps and related transformations. I'm happy to have me joined by Uday. Uday is a CTO, and he works with a lot of our customers in technical capacity and expertise he brings for transforming cloud, container, microservices journeys for many of our customers. And he brings a wealth of experience of how to do the specific technology solutions. And I'm also happy to have with me Olivier, who leads in VMware Tanzu observability business focused on APAC and EMEA markets. So with that, we'll talk a little bit about how we see key challenges in enterprises, because enterprises, they have a particular set of challenges that need special consideration on how we tackle them. So we are going to talk about them briefly. I'll set the stage so that next thing that we will do is we'll do a demo of what we call a smart signals solution. And that will help you see how we address the three challenges I'll talk about in the enterprise observability. And a part of that implementation, we also use and leverage products which do observability platforms and monitoring and open standards. Tanzu Observability is one of those products, and Olivier will help us understand a little more about how that product supports the lessons that we have learned and the solutions we have learned from that. So if we go to the next one there. So the three challenges that we have seen often, and these are particularly true for most of the organizations that we have worked with, large enterprises in particular. And the number one challenge that we see is that the nature of observability solution that we see and that we frame is also a result of the choice of paradigm that we use. And what I mean by paradigm is many times the teams in enterprises, they're very focused on uptime and availability and infrastructure assurance. The point of view they bring is that I've got these hundreds and thousands of workloads that I need to keep up and running. So the focus is entirely about what are the problems that are going to cause me system-wide issues or problems. That's the worst kind of thing that you want to avoid. And therefore, everything is focused around how do I assess impact, what is going to be impacted, and how do I mitigate or avoid that impact. And that creates one kind of or one style of solutions that we implement. The other part that we see often and that we work with quite a lot is that while that is all true, not every transaction, because transaction is of critical value, transactions are what generate money for the organization. So if you take that point of view, not every transaction is going to touch these hundreds and thousands of workloads. They're only going to touch few of those workloads. So if transactions are making me money, I need to make sure that every transaction that flows through ecosystem is up, is healthy. And if there is going to be a problem in that flow of transaction, then I want to get insight, which is in the context of transaction, so that I can take preventative actions and avoid outage or incidents in the first place. And depending on which of these, not that any one of these sites is particularly good or bad, but what is critical that we have found in our experience is that organizations often struggle to balance these 2 point of views. So if you do focus on one, then the other one, right, remains weak. If you focus on the second one, first one suffers. So that's the part that we believe needs to be addressed in a way that you can quickly switch between these two kind of thinking paradigms. The second part is if we say that transactions are important. We want to trace the transaction. We will monitor the transaction. We will go wherever the transaction goes and observe or potentially detect if there is going to be an incident and try to recover. That's not easy. That's a lot more difficult in enterprises which are, running hundreds of applications, and some of these applications was built over 10, 15, 30 years ago. So they typically run with this second problem that if I want to change the transaction, many times the transaction will flow through your legacy system assets and your cards products, your third-party applications. Recently now with cloud and SaaS, you may have those components playing a role in the transaction flow. So how do you make sure that those barriers, technology components create barriers, those barriers are overcome so that we get transaction-oriented telemetry for better intelligence, better understanding, better recovery. And that's where we believe that tools that support standardization are critically important, particularly going forward. If they are 10 years ago or 5 years ago, there were not enough open standards to support observability. Today they are. Open telemetry is definitely a standard that supports observability across technical stacks. So any solutions that we build, if they're built around these standards, they are very valuable for the long run. And the last part that we have seen is, again, it's related to paradigm, is when you observe that there is going to be a potential issue or there is an alert for a potential issue, what typically happens is that we have a support team or a production engineering team that notices that there are potentially amber or red flags, and then they do double click, triple click, drill down to figure out where the potential problem is and what remediation action is to be taken. And what we have learned is that if we actually do transaction-oriented telemetry, which represent business value, we are in a much better situation to decode what the transaction problem or potential problem means, and therefore what corrective action we could take. In some cases, that action would be, oh, I'm getting a lot of orders, I want to scale out so that all of those orders will get processed. In some other cases, that maybe I'm getting a lot of orders, but I don't need to necessarily scale out. I can simply buffer them or batch them or throttle the load so that I can still continue the process without creating an outage. So which of these actions are appropriate for a given transaction? And once you are able to decode that, you are actually able to automate the remediation action as well, so that we don't really have to think about single pane of glass. It becomes a self-sustaining, self-healing environment. And that is clearly our preference of how we want to do that. So what we will do today in the demo is really that piece that we will show, that how we bring these things together to create a self-healing environment, even in situations where some workloads are on cloud and self-scaling, right, active environments, whereas others are not, they are on-prem and they are not necessarily dynamic, right, capacity provisioning that they bring. So we will do that. And before we do that, I'll just do a quick summary of, because site reliability engineering or service reliability engineering has lots and lots of practices. So if you want to implement this kind of things consistently across a large organization, there is clearly a need to simplify this in a way that everybody can adopt and implement it in a consistent way. And that's where this page quickly summarizes how we approach this for large scale deployments. So number one thing is that for this conversation, we will focus on team that we call ASRE team. They may have different names for that: production management team, production support team, system engineering team, whatever. But their focus is really to make sure that production environments are up and running and healthy, and the transaction flows is consistently going through. The second part that we do is that no matter what team is working on this and what application assets that we are working with, the primary goal is really to measure transaction flows, because many times it so happens that application may have very high uptime, but within the context of a transaction, that uptime may not be adequate. That's what I've depicted, that depending on two different flows, the node I marked with X either may need to be 99.6% available or 99.8% available. And therefore, understanding the context of transaction flows is critically important for ensuring high flow and high business value that is delivered through all the IT assets. And the third thing that we do is, if we measure everything, that is good enough. But ultimately, the success is really in these three metrics that we need to improve. And that is mean time to recover is obviously easy to understand. If there is an incident, we want to recover quickly. The second part is you want to avoid how quickly these incidents are happening. You want to delay that. So mean time between failures really helps us focus on what are the tricks and tactics that we can use to ensure that applications are healthy for longer period of time. And the last part is the turnaround time, because these two alone are not enough. If you actually notice a problem that requires, say, for example, code fixes or changes, how good you are as an organization to turn around these issues quickly. So if we improve these three metrics, and there are hundreds of practices that can enumerate, but those all will ultimately help us improve these three metrics. And if we focus on these, then we can find a consistent way to implement this across the organization. So I'll stop there. I will invite Uday to talk to us about how he has done the demo, how he has set it up, and give us some of the learnings that he has in the process. Uday?
Yeah, thanks, Nitin. So given what Nitin said about how the metrics need to be collected, how these metrics need to be used to understand the signals, what the system is talking about from an observability perspective, and how we make the system self-healing based on those signals. So that will be the focus of the demo. So the demo consists of following components. We have a Tanzu Kubernetes grid. We have the cluster where we are running a sample application. In this case, we are running a web bank application as a web application. It has a web UI. It has account services and check services. The way we have structured this application is to have web application run its own pod and have account service, check service on different pods. One of the objectives of doing this kind of segregation is to show you the scalability of it, but also show you the dependency. So typically in enterprise applications, one of the pain point is applications are layered in terms of their services. And if some of the application components are not behaving, how is that impacting your customer, your UI? And that's how we wanted to demonstrate on how these signals can be captured early enough to avoid any downtime to the UI. As Nitin said, we have used certain open source components as part of this particular observability. We have Prometheus, Grafana, or as two components which we have put it in. We have used also Rendeck and Alert Manager more from understanding of the signals and kicking off certain remediations for it. And given the Kubernetes cluster has the capability of scale in, scale out, ability to restart a particular pod or a node, we are able to take those remediation steps with it. The whole testing we started with a JMeter, putting the load onto the web application. As part of it, we also introduced some chaos into it so that we see delays in dependent services. We see unexpected load coming in. We will see certain CPUs are being highly utilized, and how you take these signals through those metrics, which Nitin talked about, and use those signals to do remediations. So here is two scenarios which we are going to take you through. One is an extreme load. This is an unexpected load came in, 10 times the expected, typically expected during that time. At this time, we want to scale out. And this could be a signal which we can capture, and then we can scale out. And when the load goes down, the CPU utilization goes down, then we can scale in. Now, we have given a dynamic rule here of 30% of CPU utilization is one of the signal or indicator to take up. And whenever the CPU utilization goes down on particular nodes, then we know that the load has reduced, and now you can go back to scale in and go to minimal number of nodes. The other scenario which we introduced is the faults and resets. Now, this is where we use the chaos toolkit, where we introduce certain network latency. We talked about the multiple layers of services, and the check service will have delays responding to the account service. Now, how does the account service take it, and how it resolves those? And we also look at the delays or goes certain threshold, crosses certain threshold. In this case, we are given a threshold of 10 seconds. Then what it means, how the system would react of restarting that particular service, because now the responses have gone beyond certain threshold of that particular enterprise setup. So let me quickly switch screens here to show you. So So I'm going to kick off a script here, which is going to give you the load which we expect. And here are the set of pods which are running now. So we have an account service, check service. There is a notification service which understands the signals coming in and take action. And there is a web UI service. And also we'll show you as part of, so here is the cluster, Kubernetes cluster, where you see these services, pods running with the account check and the web UI. And we also have, as part of the cluster, certain monitoring components, which we talked about. And these are the monitoring services which are related to Prometheus, Grafana, Rundeck, and so on. So those will also be shown as part of this. So just give me 1 second to refresh this, probably timed out. Yeah. Okay, there you go. And the monitoring one. So you can see we are using Jaeger as part of it, Prometheus and Rundeck, and the tracing using the Jaeger. So now let me take you to the Prometheus Grafana dashboard. Here is a sample run we did earlier. And as you can see, there are multiple things going on here. We have a flow metrics. Here we are capturing the request rate. And as you can see, there are 3 lines or graph lines here. And there is a rolling average of 1 minute and 2 minute and 3 minute. So some of the these rolling averages gives us the derivation in terms of what signals to monitor for. Now we see that there is a high CPU utilization gone up to 30% around 10:10, and which is at this particular stage. Now, the way the alert is generated and the signal is captured is when you see that your 1 minute average is on par with your 3 minute average. That means you are having a sustained request rate more than 3 minutes. Now, at this time, we also monitor what is the CPU utilization. And in this case, the CPU utilization crossed the threshold of 30%, as you can see here. Now, this is a signal. So we capture this signal and we create an alert for that. And that's the alert you see here, the high CPU utilization. In this case, given that it's a Kubernetes cluster, we have the advantage of scale out. So at this time, we scale out the number of pods for that particular node. Here we are looking at an account service to address that. And then the request rate comes down slowly. And you also see that the CPU utilization comes down because now we have one more node to help with the increased load. Now, as the CPU comes down to below 15%, there is another alert raised. At this time, we see that a consistent decrease in terms of the request rate and the CPU utilization. And the alert is captured as a normal CPU utilization. Now you can scale in and reduce the number of nodes that you have increased because of the load. So that's 15%, and there is an alert raised and which is being handled. One of the other scenario we talked about is the duration. So as the system is going through the normal load, something bad happens in one of the dependent service, and the service is misbehaving, giving you longer duration times. Now, if you look at here, the service typically used to give like a 400 milliseconds, but suddenly it started spiking up. But at this time, if you look at the red line, a vertical red line, there is not enough request rates, but still we see a longer duration. So that means one of the dependent service is misbehaving for probably a technical issue. Now we do observe that. So as we see it sustains the duration for a longer period of time. And as soon as we see that the duration is not coming down and it is going up, in this case, now it has gone up to 7 seconds. Now at that time, we raise an alert. We raise an alert saying we have a significant change in the application duration. And this could be an SMTP or it could be SNMP kind of alert which we send out, which can be handled. But we also continue to monitor the situation. And as we see the duration cross 9 seconds, we know 10 seconds is when the customers will start seeing timeouts. and we are at 9 seconds. So we know this particular threshold is not good for the application from a web UI perspective. In this case, we trigger an SOS restart. Now, given again, it's a Kubernetes cluster and pods can be restarted, and we trigger that remediation to restart. Even though the request rate continues to be the same, now after the restart, we have seen the duration has come down drastically, and the system is again doing normal. Now, during this period, we have seen unexpected request rates. We have seen system handling those by scaling out without impacting customers. We have seen certain components of the application misbehaving, which is causing higher duration times. But again, that has a negative impact to the customers who are using the web UI, and we remediate it proactively. And that's why you don't see any errors in this particular case. So all these conditions are handled because we have these smart signals which we have created based on the metrics, and those signals are handled to do the remediation. Of course, all these remediations are possible because of the Kubernetes cluster and the kind of pods capabilities we have as part of the Kubernetes. But there are also other aspects of it in terms of looking at scale in, scale out, restart of those, as well as looking at individual resource level. For example, if a file system is getting filled because there is a bug in terms of a particular component, we'll be able to do a remediation script to clean those file systems. So the capabilities in terms of the remediations are as the system provides or enables. So with that, I will yield back to So Oliver, you want to pick it up on the Tanzu observability?
Yeah, sure. Thank you, Uday. Actually, yeah, I'm Olivier Fair. I work for VMware, and I'm in charge of our Tanzu observability offering across EMEA and Asia Pacific. One of the things we're working on with Mphasis is on porting the smart signals offering we just saw onto Tanzu observability to bring some of the enterprise capabilities of Tanzu observability to the offering. Tanzu Observability is an enterprise-grade observability solution that, as you can see here, can ingest kind of hundreds and thousands of data points coming from the most various sources like cloud, container, IoT, infrastructure components, ingest all of that and bring rich capabilities in terms of analytics to create metrics, histograms, alerting, span logs, and then present this in a smart context to a wide array of users within the organizations. It can be SRE, it can be platform teams trying to understand some of the challenges of some of the misbehavior that Uday was talking about in their application to quickly come to a root cause. But it can also be developers wanting to observe real-time the impact that their code releases has on the application. Through self-service capability, developers can quickly kind of themselves self-query and understand what's going on and take remediation. It can be business as well. Business leaders wanting to have kind of a higher level view on what's happening within the stack to kind of understand the impact that all of these various components that we look at, again, application, microservices, all the way to infrastructure components can have on business outcome. So this can quickly translate into transactions per minute, lost transactions, and even dollar value if we present these results to business leaders. Next one. Tanzu Observability is a SaaS format solution that focuses on observability. These are some of the areas we're working right now. We are kind of building bridges between the open source capability that Uday went through with Prometheus and Grafana to integrate them into Tanzu Observability. One of the things we're doing, for instance, is the support for PromQL, the query language, does inherent part of Prometheus to kind of make it integrated into Tanzu Observability, giving the developers and the operations team that are familiar with PromQL the capacity to leverage all of the rich functionalities that we have in Tanzu Observability while sticking to a language and environment they're familiar with. So Tanzu Observability also comes with its own language, Wavefront QL, but it's compatible again with PromQL, kind of giving the organization the best of both worlds. We also kind of working toward tighter integration with APM. We are growing the ecosystem by integrating with third-party solutions such as Terraform or other components of the the Tanzu portfolio, working with the providing a catch point integration as well to provide end user metrics and synthetics, and obviously hardening the whole security posture by doing things like metric level role-based access control, which is something quite unique, making it possible to show only specific metrics to the users of the platform at very granular level. So to summarize on the next slide, Tanzu Observability kind of distinguish itself by the high level of scale it can offer. We can run up to 2 million points per second without any challenge, and we have large organizations relying on Tanzu Observability for the daily monitoring of the platform. Another interesting aspect is the fact that we provide no rollup, meaning that any organization can go back up to 18 months in time at granular level to understand any event that has happened on the platform at this time, providing kind of rich analytics capability. Interesting as well is the breadth of the integration that Tanzu Observability offers with rich out-of-the-box integration. They are like of a very extended support for 200 kind of components and multi-stack components. We have as well the built-in AI as well to kind of keep enrich the platform. And as I said, finally, this business angle up to 100 kind of ready-made queries that really help organizations really get the fastest insight into the health of their application landscape. So just to close off on the next slide, we see Tanzu Observability very much in line with what Mphasis was covering as a great way to kind of bridge the gap between technology outcome on the left-hand side, what developers, what application team want to achieve, but also the business goals, really about supporting high uptime and user satisfaction. So this is really the best of both worlds, where you're able to kind of hit cost efficiency, de-risk strategy and innovation, while also providing developers freedom of choice by the combination of some kind of commercial software with the open source support we talked about around PromQL and a few other aspects. Back to you, Uday and Nitin.
Thank you. So thank you, Olivier. And what I really loved about Tanzu Observability is that the fact that it does support open telemetry. So it's a solution that is, first of all, it is a fantastic solution. Secondly, it is standard based. So for enterprises, it is of immense value. So that just to leave you with 3 key points that we have learned over a period of time, that always prefer open standard-based solutions. They are good for the long run. Second is Tanzu Observability does a lot of that very easy by building enterprise-scale observability. And the last part that we have learned is it is always very efficient to connect your decoding of signals to automated resolution. And more you do that, more autonomous self-healing capabilities you build in infrastructure, and then you start moving towards monitoring infrastructure assets to monitoring and maximizing business availability and value. So thank you very much for your time, and we'll conclude with that today.
All right. Thank you. A little bit of bonus content there. We are going to take a quick break. Let's get a little sugar maybe in your body. I don't know, a cookie, a brownie, maybe a cookie and a brownie. I don't know. You do you. But we're going to come back with, I hate to say it, it's my telephone provider. T-Mobile is going to talk to us about how we can modernize customer messaging. So we'll be back shortly. Cheers.